Here I'm asked to graph this piecewise function and check if it's continuous at x equals 0. And that's kind of like my breaking point here, like where I change from one function to the next. So it's definitely possible that it's not continuous. We could graph it or use algebra to figure this out. Just to talk about if it's continuous first is basically if I just plug in 0 into here and I plug in 0 into here, if I get the same value when I do that, it's going to be continuous. So when I graph, I'm going to do that anyways. So let's just kind of see how this goes. So on this one, this is all the values greater than or equal to 0. These ones are for all the ones less than 0. So I'm going to say 3x plus 4. I'm going to plug in some x values to get some y values. And I'm doing all the values less than 0. So 0, -1, -2, and that's probably fine. So when I plug in 0, I get 4. When I plug in -1, -3 plus 4 is 1. -2 into there gives me -2. And I'm just going to plot those points because it's a linear function. So this is where I have an open circle because it says just less than 0. -1, 1, -2, -2. And again, it's a linear function, so it's going to go on that general path forever. Then my red function here is x minus 2 squared, and I'm going to plug in some x and y values, or plug in some x values to get some y values. I'll do 0, 1, and 2. When I plug in 0, 0 minus 2 is -2 squared is 4. When I plug in 1, 1 minus 2 is -1 squared is 1. 2 minus 2 is 0. I'm going to plug in a couple more because I want to get that general parabola shape. 3 minus 2 is 1 squared. 4 minus 2, 2 squared. And so when I plot these points, 0, 4, it fills this point in, which tells me it is going to be continuous. What is it? 1, 1, 2, 0, and mirrored here. So there's my parabola shape. So in that one here, we see on the graph that closed circle, because the greater than or equal to fills in the open circle. And so, yes, it is continuous. Or when we're looking algebraically, when I plug in 0 to both of these functions, I get the same y value.